thank you so much, and hopefully everybody had a wonderful day one at HashiConf EU. Great to see most of you made it back for day two. I know it was a little bit of a late start. I think people were sort of dragging in this morning. So I know the reception seemed to have gone pretty well. So day one, we spent a bunch of time on infrastructure layer, applications layer, lots of fun updates there. Today, I want to shift gears a little bit, and we're going to focus in on the security and networking layers a little bit more. So I think before we kind of jump right into some of those updates, I think helpful to sort of understand how we think about them more broadly, right? We think about security and networking together as part of this sort of larger effort around zero trust, right? And I think as we're migrating our applications into cloud, this is sort of putting pressure on us to rethink a little bit of the traditional security model. It used to be we thought about network perimeters, kind of securing the four walls of the data center. And it was a very sort of, I'll call it IP-centric approach to thinking about security, right? We sort of stopped the threats at the front door, treated our private network sort of high trust, confidential, secure. And I think what we've seen over the last few years is that approach, in some sense, never really made sense in the private data center, and it makes even less sense in the cloud. And it shows up in many different ways, right? It's everything from the SolarWinds types of breaches that we've seen into, sort of attack after attack or compromise after compromise that we see in the news, related to the fact that that kind of assumption of this private network that's perfectly secure is sort of a bad one, right? So I think that's what brings us to this idea of zero trust, where really what we want to say is, there's no distinction between my public network and my private network. It's all sort of untrusted. So what I want to do is explicitly authenticate my users and my applications. I want to authorize what you're allowed to access, right? Whether it's human to system or system to system. And so that's really the basis as we think about zero trust, is how do we go through that transition? So as we think about that, there's sort of four pillars to it, right? It's about establishing human identity and machine identity, and it's about leveraging those to then in the human to machine and the machine to machine workflows. So in practice, what does that mean, right? I think it starts with establishing human identity. You want to say, hey, I know this is Arman. He works at HashiCorp. He's a member of the development team. And then I can leverage that identity in the different human-to-machine workflows to say, OK, well, what system should Arman have access to? And then on the other side of that spectrum, it's about starting with machine identity. That's where Vault comes in to say, great, I know this thing is a web application. Based on that identity, I might say, great, you have access to a database credential or a cloud API key. Then from there, I can leverage that machine identity in machine-to-machine access to say, yeah, my web server should be allowed to access the database, right? And then extending it all the way to human-to-machine, be able to say, yeah, Arman is a web developer. He has access to this web service. I need to know the identity of that web service in addition to knowing the identity of the user. So where does this all start? I think single sign-on, very well-known problem. We've been kind of doing this for a few decades. We might have done it in a traditional way on-prem with LDAP, Active Directory, other kind of traditional systems. Now in cloud might be Okta, Ping, Azure AD, lots of different approaches. At the heart, it's really about having that common user directory, being able to map a user into a group, and then some cryptographic protocol to assert, yep, this is Arman, whether that's SAML, Kerberos, OIDC, a lot of good choices. At the other end, then, is I think the less well-understood problem, right? It's how do we think about machine identity or application identity? I really want to be able to say this thing is a web server, this thing is my API service, this is my database. And that is really an identity problem, right? I want to understand that. And so people often think about Vault first as a secret manager, but the problem you have to solve even before you get to the secret is understanding and mapping that application identity. So this is where Vault integrates with all of the different platforms that we run on, whether it's clouds, Amazon, Azure, Google, whether it's app platforms like Kubernetes or Cloud Foundry, and many, many more systems, right? Vault has sort of dozens of different identity integrations so that no matter where that application's running, we can sort of figure out, great, this thing is application foo or it's application bar. What should we allow that application to do? So it starts with that. Then the first use case, obviously, and where people often think about Vault, is the secret management one. Great, I know this is application foo. It's a Lambda function on Amazon. Great, what should foo have access to? A database key, a Twilio token, a cloud key, et cetera. So I think it often starts with the static secret management, but where things get more interesting is can we use that identity to then do dynamic secrets? So in that scenario, Vault's actually generating credentials on demand. It's rotating them. And we move to this more sort of ephemeral model of credentials, right, where it's all identity-based. And I can check my Vault policy into GitHub. There's nothing sensitive about it. It's not a credential. The policy just says, yep, Lambda function foo can get a dynamic database credential. That expires every 24 hours. Right? And so Vault integrates with hundreds of different systems today, from databases to message queues to clouds to PKI and beyond to be able to do that. I think moving beyond that is then really thinking about how do you actually protect data, whether that's in transit or at rest, right? And so oftentimes what you end up seeing is an application might get a sensitive key and just write it to the database, right? Whether it's a credit card, a PII, et cetera. And so the role of Vault as we think about it is twofold. One is a key management system, right? So we don't want to actually give the encryption keys out to the application because who knows what the app will do with it, right? Does it log it to disk? Does it send it off to Splunk? Does it expose it to a user? So the moment you sort of let go of the encryption key, you lose control of it. So you don't want the keys to leave Vault. Instead, it holds on to them and it lets you do operations on top. So we might encrypt data, sign data, decrypt, et cetera. But this way, the application can use Vault and say, encrypt this for me. What I get back is a non-sensitive value. That's what I'm actually storing in a database or putting in a Kafka queue or sending out to my data warehouse. So in this way, we start to think about leveraging the application's identity to actually go one level deeper and govern their access to data. What data should you be allowed to encrypt or decrypt? What transactions are you allowed to sign? So it's really extending machine identity further out from just secret management into how we interface and manage data at rest, data in motion. So when we talk about Vault, there's been a bunch of announcements and updates over the last little bit. A big focus area for us has been HCP Vault. This is the managed Vault service as part of the HashiCorp Cloud Platform. And so over the last year, we first introduced that on AWS in a limited number of regions. We've since expanded and added additional regions, new SKUs. So you can go from the lightweight development SKU through standard production SKUs all the way up to multi-region deployment with a plus SKU. And then we've introduced multi-factor authentication as well as part of that. So continuing to invest and make HCP Vault more feature-rich, more broadly available, and different SKUs to kind of fit different use cases. Beyond the sort of managed Vault, we've also been focused on adding new capabilities into core Vault itself. So one big one that I'm super excited about is the introduction of Vault as an OIDC provider itself. So when we talk about Zero Trust, how do we actually extend that into our microservice architecture? A core pattern that we've seen over and over is to be able to use an OIDC token between our different services. So Vault can actually act as that OIDC server, generate those signed credentials, and allow us to make calls between our different services that we can then authenticate in a cryptographically secure way. Right? So this lets us extend that authentication and authorization into our applications themselves using Vault as the key backend for that. Very similarly is extending Vault's PKI support. So as we think about certificates, they're often the root of trust for how we manage machine identity, application identity, system-to-system access. And so there's a lot of pressure on improving how we manage certificates, rotate them, generate them. So a lot of work has gone into making the Vault PKI engine more flexible, supporting additional formats like SPIFFE, deeply integrating that into different systems, allowing you to use HSMs to offload and manage sort of potentially a root certificate authority offline. So lots of enhancements around PKI. And then the last one is really moving our multi-factor auth support out of Vault Enterprise and into Vault Open Source. So lots and lots of additions to sort of Vault Core in addition to sort of Vault Managed. Beyond just the core products, though, we realize there's a whole ecosystem around Vault that you want to integrate it with. Kubernetes, of course, being one of the most popular, most common platforms. So we spent a lot of time thinking about how to make Vault work better with Kubernetes. So the Vault Kubernetes integration piece is turning 1.0 and has a little over 10 million downloads since its initial launch. So very clear to us that this is a super important and common integration point for Vault. Beyond that, thinking about the Vault Kubernetes secret engine. So how do we dynamically manage service accounts with Kubernetes, enable that to be sort of rotated and treated like a dynamic secret along with databases and other systems that Vault already understands. And then the Kubernetes CSI driver to make it more native within a Kubernetes environment to be able to read it and treat it like a file system. Beyond that, thinking about UBI images. So for folks using OpenShift, these are kind of more native images designed for the OpenShift environment, and improvements to Vault Agent to make it work better within a Kubernetes environment. Next is then thinking about integration of Vault with Consul. Right? So as we think about the interplay between those two systems, again, we start by establishing machine identity. That's where Vault fits. And then Consul really fits more in that machine-to-machine access. And this really goes back to PKI and certificates being used to identify the apps and manage the authentication between them. So there's a two-way sort of deeper integration. One is driving a Consul engine within Vault that allows us to manage dynamic credentials and tokens within Consul from Vault. And then in the reverse direction, deeper PKI integration. So allowing Vault to be better used as the PKI sort of root authority for Consul, right? So really looking at how do we make it a better together experience. So with that, I want to shift gears and spend a little bit of time talking about Consul, right? So now moving and thinking about in that machine-to-machine access pattern now. And so when we talk about Consul, I think there's two really important paradigm shifts taking place at the same time. One is we're taking those monolithic applications and decomposing them now into microservices, meaning we now have a lot more applications that we're managing on a relative basis, and they're being updated much more frequently, because now each of these independent parts are being developed by independent app teams, deployed at their own cadence. And in addition, they're being moved out of private data centers and into cloud, right? So it's sort of a double whammy in terms of the complexity here, because we have more services updating more frequently, much more ephemeral, much more elastic, right? So this creates a lot of pressure on the traditional approach to managing it at a network level, which is very IP-based, typically relatively hard-coded IPs, firewall rules, much more static and brittle when we talk about this level of change. So as we think about Consul, there's really sort of four pillars of the problem that we think about, right? And so we'll kind of roll through and talk about how does Consul address each of those, but it's in this context of the shift of the application pattern, right? The first key sort of problem Consul sets out to solve is service discovery, right? Now we have all these different microservices, some on-premise, some in Cloud A, some in Cloud B. How do they all just find each other and work together? At the same time, it's no longer just VMs, right? We might have had bare metal apps in our data center, then we had VMs in cloud, now we have containers, now we're going to layer on serverless and have Lambda functions. And so all of these things need to somehow interoperate with each other, right? We didn't lift and shift all of it to a new generation. The Lambda function is going to talk to our container, is going to talk to our VM-based app. So this is where Consul thinks about being kind of a universal registry, right? All of these applications can register. Consul integrates with all these different platforms. And most recently, we added support for AWS Lambda. So now your application that's a Lambda function can register with Consul and interop with your Kubernetes container app, can talk to and discover your VM-based application across the different data centers and regions they might be operating at, right? The next major challenge is great. Now these things can all discover each other, but should they be actually allowed to talk to each other, right? How do we manage the security around the networking? Who's allowed to talk to who? And so I think this is when we really talk about more of a service mesh type approach, right? We want to move that segmentation out of a network layer where we solved it with sort of firewall rules and security groups up to the application layer. And what that lets us do is then simplify the network. Now I don't have to worry about solving it by having sort of a constantly evolving set of IP controls. I don't really care what IP things are running at because I've pushed the security up to an app layer, right? So at the service mesh layer, a lot of work has gone into making this better. We talked about the better Vault integration, so being able to back Vault's certificate generation engine and use that as part of the Consul service mesh. So if you're already using Vault to manage machine identity and PKI certificates, you can extend that into the Consul mesh. Another is deeper integrations across HCP Vault. So whether you're using self-managed or cloud-managed, those are all tightly integrated. And then extending the mesh into Amazon ECS as well. So really going back to that vision of Consul supporting multi-platform, now you can span, great, I have Kubernetes apps, I have ECS apps, I have VM-based, all of them can be part of one service mesh, right? And that's really core to the Consul vision, is this notion that it's going to be a multi-platform, multi-cloud world. The next big one is thinking about sort of the automation challenges, right? And so while it's great if we can move everything and live in sort of a modern kind of service mesh world, the reality of most of our enterprise networks is that we have hardware firewalls, hardware load balancers, hardware API gateways, specialized networking devices. We're still solving a lot of these problems at a networking layer. And so there's this sort of disconnect and challenge, which is we might talk about service mesh, but that's a small portion of most of these estates. How do we bring the rest of the network along with us? So that's where we really think about a tighter integration with Consul and Terraform. So you might hear us talk about the Consul Terraform sync or network infrastructure automation. And what we really want to enable is you're taking the identity of the applications that Consul knows about. We know, great, this thing is a web server, it's a Java app, it's trying to talk to that database. And we know the set of these Java apps in a dynamic way because of that catalog. And we can connect that to Terraform so that you can define static rules around how that firewall should be managed. So we can have a rule that says, great, my set of Java apps, those can talk to my set of databases, but I don't care what the IPs are. The moment a new Java app gets deployed, maybe it's auto-scaling on OpenShift, that registers with Consul. Consul then integrates with Terraform to rerun with the new set of IPs, and we can update the firewall in an automated way. And so what we see in a lot of environments is that lack of end-to-end automation means our developer teams, they can deploy 10 times a day, but then they have to file a ticket and wait 3 weeks for the firewall to get updated. So it sort of breaks that end-to-end automation. Versus if we can close that loop and say, great, you can deploy as often as you want, the network updates are actually automated, right? Because the policy around Java app can talk to database, that's static. The set of IPs, that's dynamic and coming and going as we deploy, right? So there's a much tighter integration here. We've just released the new Consul Terraform Sync version 0.6. That brings 20 new network modules, so spanning all of the major types of classes of network hardware and vendors, really a part of that supported ecosystem, and now extending support to HCP Consul, Terraform Cloud, and Terraform Enterprise as well. So no matter what configurations you're running, really looking at how do we achieve that end-to-end network automation. And then the last and kind of final pillar is how do we think about the sort of access to these microservices themselves, right? And so most of these are now API-driven services. And so we might want to say, great, I have applications coming in from either the public internet or from outside of my mesh, and they need to be able to reach the services running on the inside. So I might want to say, great, /foo, anything at that path goes to my foo service, /bar, anything at that path goes to bar service, and I want to be able to ingress applications into the mesh. So with our new API Gateway, we introduced that in January, really looking at how do we make that sort of a first-class north-south pattern with the API Gateway built around Envoy, right? So with the latest version, 0.3, we're adding support for the latest version of Envoy. This makes it easy to have a highly available gateway service that you can scale out. We're also supporting the latest Kubernetes API Gateway specification. So as you're adopting the Kubernetes API Gateway spec and defining what your application needs as a CRD, that will natively be able to sync with Consul and the API Gateway, and it should all just work, right? So it makes it much, much easier to just let your developers specify exactly what they need, and then let Consul kind of automate the networking requirements behind the scenes. So one of the big challenges that we've seen across all 4 of these buckets is when we talk about the deployment pattern of our teams, what we're seeing is that many of the application teams have their own Kubernetes cluster, and ultimately we want to delegate to those teams to let them manage their own networking policy. They want to be able to define what apps should be able to talk to what other applications, how routing should work, manage their API gateway rules. And so we don't necessarily want a central networking team to have to define and manage all of that. So with Consul administrative partitions, what you effectively get is a subset of Consul, almost like a virtualized Consul. So you can run one logical set of Consul servers, but then delegate out to each of these partitions ownership to those application teams. So then they can self-serve, managing their own rules, which apps can talk to which apps, how their network should be sort of configured. But you don't have to run a dedicated set of Consul instances for every one of those application teams or every one of those partitions. You sort of can run a virtual Consul effectively on top of it. So with the new version of Consul 1.13, we're going to extend that administrative partition support into multi-data center as well. So you can have application teams that say, great, I have a kube cluster running in France. I have a kube cluster in US East 1. Both of those are owned by the same application team, and I need traffic to flow between them. And now that can all work with administrative partitions. As part of making that work, we're also starting to improve and change the way Consul federation works. It used to be that it was a very active-passive model. You had a single active data center. It would replicate the rules and policy to all the other passive sites. And what that meant is effectively you only had one management domain. One team had to manage the active site, and that replicated globally. And so that had limitations if you had multiple teams that wanted to operate their own Consul clusters and be able to do things their own way. So now we're sort of changing that model with cluster peering and making it a little bit looser. Each line of business or each application team can run their own Consul cluster. They may not necessarily trust each other fully even, but they can have a loose cluster peering relationship and say, great, there's a subset of my services I'm going to expose to you. There might be a subset of services you want to expose to my Consul cluster. So we can allow that networking and discovery to happen across those cluster boundaries, but they don't all have to be managed by one team. They don't all have to be sort of centrally administered. So this starts to enable a much more flexible model where you don't just have to have a single active and many passive regions and have a looser connection. So all this is part of Consul 1.13. That'll be available later in July, and there'll be some great sessions today that'll go deeper into all of this stuff. So encourage you checking out and learning more about all these new features. Next, I want to talk a little bit about Managed Consul. So we introduced this last year with HCP Consul, initially on AWS. So super excited to announce now we're starting to extend that out of just AWS to Azure as well. So HCP Consul on Azure now in public beta. You can go and kick the tires. And this will be going generally available July 15. And so now I want to take a quick moment to hand it over to Brendan Burns. You might know him as the co-creator of Kubernetes, also CVP at Microsoft. So I want to hand it over to him to have a quick word from Brendan.
Thanks, Armin. Hello, everyone. I wish I could have been there with you at HashiConf to celebrate this announcement of HashiCorp Cloud Platform Consul on Azure, a fully managed service networking solution for Azure customers. HCP Consul provides native integration between the Consul service mesh and the Azure Kubernetes service. Consul users are likely familiar with its service discovery capabilities, but Consul actually provides a complete service mesh that enables you to easily achieve both connectivity and security between your microservices developed in Kubernetes. You know, Azure Kubernetes is the fastest growing service in Azure because it enables you to take advantage of cloud-native development patterns while Azure handles the complexity of managing the open source platform. And HashiCorp Cloud Platform Consul on Azure provides the same benefits. It delivers reliable and easy-to-use service mesh technology based on HashiCorp's Consul open source project. With Azure managing Kubernetes and HashiCorp managing Consul, you can focus on building cloud-scale applications instead of managing infrastructure. The ability to connect multiple different clusters or clusters and virtual machines is a core strength of Consul. And with HashiCorp Consul on Azure, you can connect any number of virtual machines or Azure Kubernetes clusters into a HashiCorp managed virtual network. Because real-world applications are often a mix of cloud-native and legacy infrastructure, HashiCorp Consul on Azure makes connecting all of these different pieces of infrastructure easy. And another critical part of any cloud-native application is infrastructure as code. And you know, Terraform is one of the most popular tools for infrastructure as code, and it's also a great collaboration between HashiCorp and Azure. Our shared Azure Terraform provider powers declarative management of all of the resources you need for your cloud-native applications, from the Azure Kubernetes surface to the HashiCorp Cloud Platform. And if you're just getting started with infrastructure as code, there's lots of great examples on the HashiCorp Cloud portal to get you started. With tools like Consul and Terraform, we're seeing joint Azure and HashiCorp customers transform their application development using cloud-native patterns to increase their team's agility and their application's reliability. We're incredibly excited by the power and potential of open source combined with the expertise of Azure and the HashiCorp teams. HashiCorp Cloud Platform Consul is a great service mesh solution for securely connecting your AKS and VM-based applications. Thanks again for letting me talk to you all today, and enjoy the rest of HashiConf. Back to you, Armin.
Awesome. We wish Brendan could be here in person, but he had a conflict, but glad he was able to kind of join us a bit virtually here. So that was everything that we had slated for Consul. I want to shift a little bit now and talk about Boundary. So this is now the third pillar if we talk about sort of going back to that sort of four-pillar view, right? Again, started with the human identity, SSO, machine identity, that was Vault. Now machine to machine, you can kind of see where Consul slots in on solving various challenges from discovery to managing access to network automation. So the third pillar there is really about that human to machine access, right? So what about our human users? I'm a developer, I need access to a production database, or I need access to a web service to be able to debug something happening. That's where it fits into a different category. And so when we talk about that traditional challenge, the question is, how did the users actually get access to those environments, right? So I think it's useful to just understand typically what do you see. Often it starts with the user having to first connect onto the private network, right? So this might be we're either going through a VPN solution, or maybe we have an SSH bastion host that we're connecting to. And so I think the first problem that we start to see with this is, A, how do we actually give people access to it? Now I need to manage a set of VPN credentials, or I'm distributing a set of certificates, or as we've all seen, there's the master SSH PEM that all of our developers have access to. They give you access to that bastion host. And so the first problem is now I have this new credential I have to manage, right? I have to onboard users onto this. And once they connect, they have access to my private network. So the second problem becomes, OK, great, just because you're on my VPN doesn't mean I want you to access everything that's in my network, or just because you came in through the bastion host, you shouldn't have access to everything that's on the network. And so the challenge then becomes, how do I put a firewall that's going to restrict what you can reach, right? And so now I have a second level of problem, which is I have to manage a set of firewall rules, right? Which is, OK, great, if I'm a developer, maybe I have access to the database. But if I'm a business admin user, I should only have access to my BI tool. Well, my firewall doesn't know the difference between those two. What it sees is a set of source IPs and destination IPs. So you can't really distinguish. It makes it very hard to have a least privilege approach, where I'm saying only what you need access to can you get to over the network. You kind of have to get to a superset from the firewall, right? The other problem is now as I'm going from sort of more static monolithic applications into much more modern, great cloud-based, containerized, maybe serverless, the IPs are not static either, right? What's the IP for my Lambda function? I don't know, right? It only lasts for a few milliseconds. And so you end up with this problem of like, do I just whitelist the entire subnet, right? At which point, what is my firewall actually doing? So then my third problem is, OK, great, I make it past the firewall. Now I actually need to get the credential to, let's say, the database to connect to it. That system should record what I'm doing so I'm not exfiltrating data. So now I have to jump through another system. I have a different set of username and password. I have another set of user groups to manage. I have another set of static credentials for the database that I have to keep up to date. And so that, the client has to go fetch it through that. And then ultimately, I can go connect to my target database. Most of the time, the user is actually using the username and password because they're checking it out, and so they see what the username and password is. And so it creates another opportunity for that credential to get exposed or leaked, right? So that tends to be the end-to-end path we see in these sort of privileged access management systems. And so we sort of looked at it and said, OK, you have a bunch of different problems here, right? One is this sort of fights the dynamic nature of cloud. Things are coming and going, but I have a whole bunch of rules I have to keep managed. Two, when I think about zero trust, I'm having to deal with a whole lot of credentials, policies, keeping a bunch of things up to date. It's hard to do this in a least privileged way. So we sort of looked at all of that, and that was our motivation for Boundary. So when we talk about the approach Boundary takes, we try and invert this a little bit, right? It starts by saying, great, as the user connects to the system, we don't want them to have a separate certificate, right? We don't want them to have a separate username and password. We want to go back to that human identity that we've already established. Right? So if we know this is Arman and he's a member of HashiCorp and he's a developer and great, he has an Okta identity, let's just leverage that. So it's about integration with that system and using that to do a single sign-on. Then the next piece of that is we don't actually want to give network access. So unlike a VPN type of a thing, we're not going to put you on the network. Instead, you have to authorize exactly what set of systems the developer or the user in this case has access to. Right? And so that authorization is going to be based on a sort of logical service identity. I don't want to talk about a set of IPs because those are going to come and go. I might want to say, great, Arman as a member of developer has access to that Lambda function or anything in Kubernetes that's tagged web, right? Or anything in Consul that's registered as, database foo, right? And so that logical authorization sort of hides and shields us from the dynamic nature of cloud, right? That container running in Kubernetes, it might be in an autoscaler that's coming and going. So the IP is changing. So I don't want to manage the IP. I want to be able to just say, great, anything based on that selector is what I care about. Right? So really trying to mask the dynamic nature. So what this then enables is when the user logs in, great, they can select from that sort of catalog what's the system you're trying to connect to based on what you're authorized to reach. You don't actually need to see the IP address. You don't actually need to know how to connect to it. You just need to be able to effectively double-click on it through a list, right? And at that point, Boundary is directly acting as the reverse proxy, connecting only to that target rather than putting the user onto the network itself, right? As part of that, as you can imagine, right, this integrates with Vault. So it might be that the credential that I need, for example, the database credential, we can actually fetch that out of Vault and use the fact that Vault can do dynamic secrets to create a credential that's unique to that one session. So the moment the user double-clicks on that database, we talk to Vault, say, generate a dynamic credential for it. That gets injected as part of that one session. And the moment you disconnect from that session, talk to Vault and revoke that credential. So we don't need to manage a set of static credentials. It can be a just-in-time credential that's created for the session, deleted as part of the session, and the user never has to even see it when they connect to the endpoint system. So really thinking about how do we modernize this so that, great, from a user's perspective, there's one tool I'm using end-to-end. From an administrator's perspective, I only have to manage one logical system with a logical set of rules rather than fighting static IPs, static ports, static hosts, et cetera. Right? So super, super excited to announce that today we're introducing the HCP Boundary Service, and this is going into public beta effective immediately. So lots of great upcoming talks. I've skipped over a bunch of updates of Boundary and sort of the last few releases. There'll be some great deep dives later today, so I encourage checking that out and going and talking to the folks at the HashiCorp booth, or better yet, just sign up and start kicking the tires right away on it. So super, super excited here. I wanted to just take a moment, maybe just showcase a little bit. I think as you log in, I think what you'll see is, great, this is an example of what defining a target to a system actually looks like. Right, you can see a target then becomes that sort of logical authorization point. So here we're going to say, great, I might have that primary website service. You're allowed to SSH into that. Or we have a database. You can have a TCP connection into that. But we're sort of going to try and hide from the users a bunch of the details of what you actually need to know. You don't really need to know what's the host IP of that thing. How do I actually connect to it? This sort of doesn't matter. Right? The whole point is we're shielding you from that. But at the same time, now we actually can get a logical view of what are all of the sessions that users have established. Right? So because we're sitting in that middle and we're not just giving you network access, we can actually see every session that the users have initiated. So in this case, we can see, great, here's the last few sessions. One of them is actually still active. We could go in and actually kill that session if we wanted to. And we can see the history of other users and what systems they've actually accessed. Right? So this is really about elevating and thinking about more of a session-oriented view, having a strong notion of user identity, which user is accessing which systems, and being able to create sort of a rich experience around that. Right? A lot more to that experience. I won't have a chance to cover it here. But taking kind of a quick step back, hopefully starting to get a sense that, yes, these are all independent tools, right? When we talk about Vault, when we talk about Consul, when we talk about Boundary, they're all their own standalone tool. They don't necessarily require each other. They can all be used in isolation. But they're all part of a much broader sort of theme here, which is how do we think about this transition we're all going through from treating our data centers where it's about securing the four walls and having a high-trust confidential network towards this world where we say it's about low trust or zero trust. I don't trust my network fundamentally. I'm not making a distinction between public and private network. I'm not saying we should throw away the private network. It's still a good line of defense, but it should not be our last line of defense. Right? So as part of that theme, it's really thinking, what are those pillars that you have to put in place to do that transition? In our view, it's about a transition to identity as the unit of control as opposed to IP as the unit of control. And so when you go through that, it's about first establishing it and then leveraging it in those key workflows. Right? So we're deeply invested in zero trust. We think that's kind of the future of where cloud security is going. At the same time, we believe this stuff is complicated, and so people don't necessarily want to have to manage and operate all of this. So all of these products are available as part of the HashiCorp Cloud Platform. You're going to see us continue to invest in that both deeper and wider in terms of platforms and configurations. And so I encourage you, go check out a bunch of the sessions. We're going to have a lot of deep dives today around Vault, Boundary, Consul, how they can work together. So a lot more to come. So with that, thank you all for joining again for day 2 of HashiConf. Hopefully you have a great time, and hopefully see all of you back next year. Thanks so much.